What happens after December 19th? The future of interstellar comet 3I/Atlas. December 19th marks the most anticipated moment in the journey of interstellar comet 3I/Atlas, its closest approach to Earth. But this date is not the end of the story. In many ways, it is the turning point. What follows after this flyby will determine how long the comet remains visible, how its activity evolves, and what scientists and observers can continue to learn from this rare visitor as it begins its long departure from the inner solar system. After passing Earth, 3I/Atlas will not slow down or turn back. Its trajectory is hyperbolic, meaning it is not gravitationally bound to the Sun. Once it moves beyond the region of strongest solar influence, it will continue outward, eventually leaving the solar system entirely and returning to interstellar space. But before that happens, several important phases still lie ahead. Moving away from Earth and the Sun. In the days immediately following December 19th, the comet will begin increasing its distance from Earth. At the same time, it will continue moving away from the Sun, gradually receiving less solar energy. This reduction in solar heating will have a direct effect on the comet's activity. The gas and dust production that intensified near perihelion is expected to slowly decline. Jets that were driven by sublimating ices will weaken, and the coma surrounding the nucleus will begin to shrink. However, this process is not instantaneous. For weeks after the Earth flyby, 3I/Atlas may remain active enough to be observed with telescopes, especially if residual heat continues to drive out gassing from subsurface layers. Changes in brightness and appearance. As the comet recedes, its brightness will steadily decrease. The once prominent coma will become fainter, and its tail structures may lose definition. Observers may notice that the comet transitions from a dynamic, structured object into a more diffuse and ghostly glow. Interestingly, some features may persist longer than expected. Dust released earlier in the journey can remain visible even as gas production drops. This means that while the comet itself fades, its dust tail may still scatter sunlight, creating a lingering signature in the sky for a short time. Over the coming weeks, astronomers will carefully monitor how quickly this fading occurs. The rate at which 3I/Atlas loses brightness provides important clues about its composition, internal structure, and how deeply solar heating penetrated during its close pass. Trajectory and the role of outgassing. One of the key questions after December 19th is whether continued outgassing will measurably affect the comet's path. Asymmetric jets can act like tiny thrusters, slightly altering an object's trajectory. While these changes are small, they are detectable with precise tracking. Any observed deviations will help refine models of non-gravitational forces acting on interstellar objects. This is especially valuable because interstellar visitors are still poorly understood compared to long-studied solar system comets. Despite these subtle effects, the overall direction of travel will remain the same. 3I/Atlas is on an outbound path that will carry it past the orbit of Jupiter in early 2026 before it accelerates into the outer solar system. The Jupiter passage. In the months following the Earth flyby, 3I/Atlas will approach the region dominated by Jupiter's gravity. While it will not pass close enough to be captured, this alignment provides another opportunity to study how a massive planet influences an interstellar object. Jupiter's gravitational field may slightly bend the comet's trajectory, adjusting its exit angle from the solar system. Observations during this period will be crucial for understanding how giant planets interact with high-speed interstellar visitors and whether such encounters can significantly alter their paths. Final observations and data collection. As 3I/Atlas moves farther away, observational opportunities will gradually diminish. Professional observatories will continue tracking it as long as possible, pushing instruments to their limits to extract faint signals from the fading object. These final observations are critical. Post-perihelion data reveal how the comet cools, how quickly its activity shuts down, and whether any delayed reactions occur within its interior. Comparing pre- and post-flyby data allows scientists to reconstruct how the object responded to its first major solar encounter in millions of years. Even as the comet becomes too faint to see directly, its legacy will live on in the massive datasets collected during this passage. Leaving the solar system. Eventually, 3I/Atlas will cross beyond the orbit of the outer planets and slip into the distant reaches of the heliosphere. As it does, the influence of the Sun will weaken, and the comet will once again enter a cold, dark environment similar to the one it came from. Once it exits the heliosphere, it will resume its silent journey through interstellar space. It will carry with it chemical signatures shaped by both its original star system and its brief encounter with ours. From that point on, it will be effectively unreachable, fading into the background of the galaxy. Why the aftermath matters. The period after December 19th is not just an epilogue. It is a critical phase for understanding the full life cycle of an interstellar object passing through a stellar system. How quickly activity fades, how the trajectory evolves, and how the comet responds to decreasing solar energy all provide insights that cannot be obtained from the flyby alone. Each piece of data helps answer larger questions. How common are interstellar objects? How do they evolve when they encounter stars? And what do they reveal about the diversity of materials that exist beyond our solar system? A brief encounter with a lasting impact. 3I/Atlas will not linger. Its visit is fleeting, measured in months against a journey that spans millions of years. After December 19th, it will begin the long road out, leaving behind only observations, measurements, and unanswered questions. For a short time, this interstellar traveler passed close enough for us to study it. What happens next will complete the story of one of the rarest cosmic encounters ever observed, a story that will continue to shape how we understand objects that move between the stars.